My name is Justeen Olinger, and I'm a junior in electrical engineering. I heard about the AMP lab when I was talking with Dr. Sweeney about current labs and how I was not very happy with how they were organized and the lab experience that I was getting through the classroom. So he suggested the AMP lab, and I had no idea what the AMP lab was. So he got Bob to send me an email showing the background of the AMP lab and how it was founded. And I thought, oh, this is awesome. I should get involved with this. So I went to the next meeting, and so here I am as a member. The first semester I started in the fall, last fall, and I really didn't get to do as much hands-on as I thought I would in the beginning. I had rather unrealistic expectations about how much I actually knew and how much I would be able to get done in a finite amount of time. So I didn't get to do much hands-on, but I did research a lot on a motion to energy project. More specifically, I was interested in turning the motion of walking into energy that would load a battery, for instance. So I was hoping, unrealistically, to get a product in my hands by the end of the semester, and that didn't happen. However, I was able, through my research, to write a proposal that won honorable mention for the Goldwater Scholarship, which is a national merit scholarship. So that was totally a straight, that was a result from the AMP lab. So that was one plus that I got last semester. This semester, I really wanted to get something hands-on and something that I could see working. And so it took me a while to figure out what I wanted to do, but I decided, after seeing a cat whisker radio on one of the slides in my communications class, that would be really cool to do. I mean, you use a pencil and a razor blade and wire to make a radio receiver, and you can actually supposedly hear something. I haven't actually gotten it to work, but I have accumulated the materials and built most of it together, and I'm really hoping to try it out and make sure it works. There were a couple of boo-boos in the entire process of making it because I'm new at hands-on stuff. So the first coil I wound was not made with coated wire, so it's the equivalent of a cylinder that will not actually act as an inductor or as a coil. So I couldn't get my hands on actually thinly coated things, so I tried making some out of the normal lab kit wire that we got. So I really want to try it out and see if it works, and compare it with what I have, because I was then able to make one out of normal thin wire. The razor blade that I had to use, which in connection with the pencil makes a diode, if I'm remembering correctly, that razor blade either has to be blued with a blowtorch or rusted. I really wanted to try the blowtorch, but it was a little bit more convenient to rust it with salt. So that's what I did, and so far I've connected it together with paper clips and tacks and wire, because that's easy and it's things I can easily get my hands on. And I still need to get a ground and an antenna and a place to actually try it all out. And I'm really hoping to try it. And so that's what I've done this semester in the AMP Lab. Next year, I would like to, I would really like to get back into motion to energy and try building something that works. I know there's a lot going on, or there's a lot of research there, and there really hasn't been anything effectual up to this point, so it's definitely an area that can use some more perspective. So I would really like to get back into that next year with the AMP Lab. Alright, so you can see here, this is the razor blade. I probably might want to rust it some more because it's not exactly, you can't look at it and say, oh, that's a rusty razor blade, but you can see that here I used that out-of-shape safety pin in conjunction with the pencil to connect to the razor blade because that gives me a good, it gives me a good pressure behind the pencil, and I can change that pressure.